Hi students, in the last lecture I have discussed moment of inertia. Let us now continue. Right, let us take a uniform ring. So taking a uniform ring, take mass equal to m, radius is r. So we want to calculate moment of inertia of the ring about an axis passing through center of the ring and normal to plane of the ring. Suppose ring is now in xy plane. If ring is xy plane, we are taken now, it is along z axis. Suppose center is now origin. It is in xy plane. Then axis is along z axis. Okay. So we are calling as its own axis or geometric axis. So we want to calculate now moment of inertia of a uniform ring about its own axis. That means axis is passing through center and normal to plane of the ring. Then see how to calculate. So I equal to definition part is integration of r square dm, right? You can see each and every point mass, each and every point mass on the ring is at same distance from the center. Suppose taking a mass dm, its distance from center, it is a capital R. If you take one more dm, its a distance from center, again r. So each and every point mass on the ring is at the same distance from the center. That means we can take now r square outside. It is now integration of dm, and this gives us mass of the ring. That means it is equal to mr square. Okay. So moment of inertia of a uniform ring about its own axis. That means axis are passing through center of the ring and normal to plane of the ring. Okay. And here if you observe, even though distribution of mass not uniform, answer remains the same. See how it is. When you are taking this a calculation part, integration of dm, this is giving us total mass, right? So here distribution of mass is not, means need not be uniform. Means even though distribution of mass is not uniform, no change in the result. Okay, right. Let us consider circular plate where distribution of mass is uniform. So we are taking now circular plate. This is now circular plate, or you can say disc. Okay, this is ring. Then see how to calculate. So this disk can be taken as a combination of rings, right? So here we can take, imagine one ring. Imagine one ring, radius equal to small r. Okay, this is mass capital M, radius is capital R. So we have taken now one ring of radius small r and its width equal to dr. Okay, so this width, that width is now how much? It is dr. So for this ring, see what is moment of inertia about its own axis. Whenever we want to calculate moment of inertia, we have to mention about which axis. So here we are calculating about an axis passing through center of the disk and normal to plane of the disk. Okay. And just now we got for a circle about its own axis, it is mr square. So here also same thing, right? So here we can write for this ring, moment of inertia, I'm taking as di, that is equal to its mass. See how much its mass, or let us take it as dm. Its mass is dm. Radius is small r. So dm into r square. Using now this result, okay, mr square. Its mass is dm. Radius is small r. Okay. In the place of dm, see what we can write. Since distribution of mass uniform, we can write here total mass is capital M, total mass capital M dividing with area pi r square. Okay, that is mass per unit area. Okay, multiply with area of this circle. Students, you should be very careful here which area we are taking. I am drawing separately diagram. This is now the ring which we have taken. So this is a ring which we have taken, and in that we are finding, so we are finding area of this part, okay, because we want mass of this part, okay, mass of the ring. When you are taking a ring, its mass means we have to focus only mass of this part. So for this part, what is area? Okay, for this part, what is area means we can take like this. If you cut this one, if you cut this one, see what we get. So we get a rectangle, right? If you cut this ring, we are going to get one rectangle. Rectangle. We want area of this rectangle. Its length equal to 2 pi r. Length is 2 pi r. And this breadth equal to dr. So I hope you are getting this. We want mass of this part, not entire part. Okay. Mass of this part. So area of this part is. So to make it simple, what I am saying is cut this one. Then this becomes a rectangle, right? This length equal to 2 pi r. Length 2 pi r. This breadth equal to dr. So area equal to 2 pi r into dr. In fact, we have taken same calculation while discussing center of mass. Okay, right. Now substitute this in this one. So here pi and pi gets cancelled. Remaining, we want I value. So I equal to integration of di. Integration of di. That is equal to, in the place of dm, substitute m by r square into 2r dr. M by r square into 2r dr and into r square. So take constants outside. Constants 2 capital M upon r square. Remaining r square r cube. Integration of r cube dr. Okay. So like this, we have to consider all rings from r equal to 0 to up to capital R. So we have taken the disk as combination of rings, or you can say circular plate. It is a combination of rings. And remaining just calculation part, it is 2m by r square, r cube dr. It is r power 4 by 4. Now take limits. It becomes r power 4 by 4 after having limits. Okay. So what is left here? 2. Here 2 times r square. R square is left. So m r square by 2. Okay. So this is now moment of inertia for a circular plate, or you can say disk, about its own axis. That means passing through center and normal to plane of the disk. Okay, right. Let us now focus on perpendicular axis theorem. Okay, see what is it and how to get it. And after that, I'm going to discuss parallel axis theorem. Okay, so coming to perpendicular axis theorem, it is only for planar bodies, or you can say two-dimensional bodies. Coming to parallel axis theorem, it is for all bodies, like two-dimensional bodies, three-dimensional bodies also. Okay, let us now discuss in detail. So first one, perpendicular theorem. Consider one planar body, means two-dimensional body. It can be any shape. Let us take it is in xy plane. That body is now in xy plane. Okay, so it is in xy plane. So this is x-axis, and this is now y-axis. So for this two-dimensional body or planar body, we want to calculate moment of inertia about x-axis, about y-axis, and about z-axis. Z-axis means normal to plane of the body. Okay, see how to calculate. Let us consider one point mass. Its mass is dm and coordinates are x comma y. So we have taken one point mass, that is dm. Its coordinates x comma y. So about x-axis moment of inertia. So we have to take all point masses. We have to calculate ix equal to we can see its distance. Its distance from x-axis, that is equal to y, right? It is y. So mass is dm into y square. That is moment of inertia of that point mass about x-axis, because distance equal to y. Like this, we have to take all point masses, then we have to take sum of all those things. That means we have to integrate. Okay, so integration of y square dm, that is ix. In the same way, about y-axis, integration of from this axis distance how much? It is equal to x. Okay, from this axis distance equal to how much? It is x. So it is now dm into x square. Okay, now if you want to calculate about the axis, integration of its distance from origin. See how much? Here the axis means normal to plane of the body, right? From that axis, distance equal to square root of x square plus y square. And we want square of the distance, right? It is x square plus y square. That means dm into x square, that is iy. Dm into y square, integration of that is ix. So it is equal to ix plus iy. This is what we call perpendicular axis theorem. Okay, that means if you are taking a body in one plane, let us say xy plane, then iz equal to ix plus iy. This is known as perpendicular axis theorem. Let us see how to apply this. Just now we have discussed for a uniform ring, its mass is m, radius is a uniform ring. Let us take this is now x-axis. This is x-axis. And this is now y-axis. And z-axis is now normal to plane of the ring. Z-axis is normal to plane of the ring. Okay. So we got the value IZ means about its own axis. Its value mr square. Okay. And you can see distribution of mass about x-axis. Distribution of mass about y-axis. Both are same, right? That means about x-axis I value, about y-axis I value, both are same. Because if you take any diameter, you can see this x or this y. Now they're becoming diameters for the ring. So you can see about any diameter, distribution of mass is same. That's why, because where condition is here, ring is uniform. Since ring is uniform, about any diameter value will be same. That means we can write Ix is equal to Iy. Okay. Now, by using this theorem, we can write Ix plus Iy equal to Iz. That means 2Ix, or I can say 2Iy, because both are same. That is equal to Iz. And Iz how much? Mr square. That means Ix is equal to Iy. That is equal to mr square by 2. That means moment of inertia of a uniform ring about any diameter is mr square by 2. Okay. Next. So we can do same thing for circular plate. It is for circular plate, or you can say disc. This is a plate, or you can say disc. Again, same story. This is x-axis and this is y-axis. Now there are diameters for the disc. You can see about x-axis distribution of mass, about y-axis distribution of mass. Both are same, right? That means again here also we can say Ix equal to Iy, because we have taken that distribution of mass is uniform. And we have discussed that about z axis. That means passing through center and normal to plane of the disk, that is z axis, that is equal to mr square by 2. This is what we have discussed just now, right? So from this what we can get, again same logic, 2Ix equal to 2Iy, that is equal to Iz. That means Ix equal to Iy, that is equal to mr square by 4. That means for a uniform disk or for a circular plate about any diameter, moment of inertia is mr square by 4. Like this we can apply. Okay. And see next one. It is parallel axis theorem. Let us see what is it. So now this is for any body. That means it is two-dimensional bodies, or you can take three-dimensional bodies. It is for all bodies. Let us take here. This is one rigid body. Let us take This is now, suppose this is now center of mass, about center of mass, about center of mass, moment of inertia is IC. Okay, let us take now, this is point A. We want to calculate now moment of inertia about an axis passing through point A. Okay, and take separation between these two. It is now D. Separation is D. And to make calculation simple, let us take center of mass is at origin. It is at origin, and coordinates for this A, D comma 0 comma 0, means we have taken this on x-axis, right? Okay, let us take one point mass somewhere here. Its mass how much? Dm. Okay, and its coordinates, x comma y comma z. Okay, so we want to calculate now moment of inertia about an axis passing through point A. So, and we want to derive relation about A, that is I, it is equal to IC plus m into d square, where m is mass of the body, d separation between these two axes. Condition is that both axes must be parallel. Okay, we are taking axis passing through point A, axis passing through point C, and these two are parallel, right? In that case, I equal to IC plus mx square. Okay, this is what we have derived. Let us see what we can do. About A. See distance of this point mass. So here what I have to do is I equal to integration of r square dm. This is now definition part, right? Integration of in the place of r square. See distance means how much? We can see here x and this is d. So it is x minus d whole square, right? 0 and this is y. So y minus 0 whole square plus z minus 0. Sorry, don't take 0. Z minus z whole square. We should be very careful. Why we have taken z minus z? It is why we have taken z minus z. See, we are taking the distance not from that point. We are taking the distance from the axis. Remember, what is here r square? Or you can say what is r? R is the distance of this point mass from the axis. It is not from this point. So both are not same. Okay. So here from this axis means axis is now passing through this point. We are having many points on the axis, right? From that axis now distance how much? X minus d whole square plus y minus 0 whole square plus z minus z whole square. It is not z minus 0. If they ask distance from this point, then z minus 0. But we are finding distance from the axis. Okay. Into dm. Right. Now remains the calculation part. Expand this. X square plus d square plus y square minus 2xd into dm. Okay. Now in this, I am taking integration of, see, d square is a constant. Okay. I am taking d square outside, integration of dm. Okay. Plus x square plus y square. See, what is that? That is r square, right? Integration of r square dm, right? This is now r square means distance of that point from, we can say from where, distance means it is r square into dm, right? Next, see what else left here, minus, I can take 2 and d outside, 2d outside, integration of, x dm. Okay, right. Now see calculation, d square is a constant, integration of dm, that gives total mass. So it is m d square, right? Plus integration of r square dm. Okay, integration of r square dm. And this becomes now moment of inertia, right? About center of mass. Because this is 0, 0. So x minus 0 whole square, y minus 0 whole square, right? This is now z minus z whole square. Why it is like that means, because we are finding distance from the axis. It is not from origin. Okay. Therefore, this becomes now IC. Moment of inertia about center of mass. Okay. Next, coming to this part, see carefully. While discussing center of mass, we have discussed that xm is equal to xm equal to integration of x dm upon integration of dm. Okay. And we have taken center of mass at origin. That means xm value how much? It is 0. It is 0 means here you can see denominator is not 0 because this is now total mass which is non-zero. So total value 0 means numerator must be 0. So from this we can write integration of x dm is 0. So this is now 0. So we got now I equal to IC plus md square. Okay. This is known as parallel axis theorem. Okay. Let us see how to apply this. Suppose we are taking uniform ring. Okay. This is uniform ring. So we want to calculate moment of inertia of the ring about tangent which is in the plane of the ring. We are taking now one tangent to the ring and it is in the plane of the ring, right? So about this axis, what is I value? So now, just now we have discussed that about any diameter for a ring, I value is mr square by 2, right? Now this axis is a parallel to this axis. This is nothing but IC because this axis is a passing through center of mass. This is IC. About this, that is I value. This is I which we want to calculate between these two axes. Separation equal to R. Therefore, I equal to IC plus MR square or MD square. So IC value MR square by plus MD square, that is MR square. So how much it is? 3 by 2 MR square. So for a uniform ring about a tangent in the plane of the ring, I value is 3 by 2 mr square. Okay. Suppose we are taking tangent normal to plane of the ring. Normal to plane of the ring. See how that appears. It appears just like a dot. Means it is now normal to plane of the board. It appears just like a dot. Okay. Now this axis is a parallel to its own axis. Own axis means passing through center and normal to plane of the ring. Right. That means now in this case, about this tangent I value I equal to about own axis mr square, right? Plus separation equal to it is r, again mr square. It is now 2mr square. It is now 2mr square because this is a tangent normal to plane of the rings. This is normal to its own axis. Sorry, this is a parallel to its own axis. Okay, that's why it is mr square plus mr square 2mr square. Now we can take same logic for circular plate, or you can say disk. Then see what happens. Taking tangent in the plane of the plate, in the plane of the plate. Again, as this same logic, no change in that. Its value how much? It is equal to about its diameter. It is mr square by 4, right? For a plate or for a disk. About any diameter value is mr square by 4. Separation equal to r. So plus mr square. So total value how much? It is a 5 by 4 mr square. Okay. Now take one more tangent which is normal to plane of the disk. It is normal to plane of the disk. Then see that will be parallel to its own axis. I am taking tangent normal to plane of the disk. It is a parallel to its own axis. Then I value will be it is equal to about its own axis mr square by 2. Okay. Plus separation r. So mr square. So total value how much? 3 by 2 m r square. Like this we can use parallel axis theorem. Okay.